Now, when you look back at this example under linear interpolation, we are saying the table below shows the values of x and the corresponding values of a function f of x. So we have a function f of x, we would probably call now curve y, and we have the values of x. And the question is, for x, when x is 0.3, we have fx at 3.00. When x is 0.6, we have this. When x is 0.9, this one happens. When x is 0.2, this one happens. Now the question comes, find f of x when x is 0.4. The first thing that you do, you look for where 0.4 lies from the values of x. When you go back here, 0.3, 0.6, 0.9, and 1.2. The question is, where do we find 0.4? Do we find it below 0.3? The answer is no. If it is no, ask, is it after 0.6? If the answer is yes, then do the needful. If the answer is no, realize that 0.4 is between 0.3 and 0.6. So if this one happens, you extract another table. Pick up a table that has the two successive values in between which you have what you want to find. Now, if this is the case, you're going to put off this table 0.3, 0.6 with the corresponding value of 0.4 put in, but not showing f of x because we don't have f of x for 0.4. Remember, it is an estimate scale. We cannot get a real value. So when you look at this, in your solution, you extract a table. It is x, f of x. From the values of x, we have 0.3, which corresponds to 3.00. We have 0.6, which corresponds to 3.22, and we have the value of x 0.4, which lies in between these two successive figures, which is 0.4, which corresponds to the function f of x we don't know. If we say f of x maybe is y, if we let the value of x be y, for f of x equals y, when x is 0.4. This is what I've done. In this sense, now look at it. When you look at our equation or the formula, the form that can be used to calculate the linear interpolation, now that we have the unknown y, start with the unknown to make it easy. So if you make this is 1, assuming this is my y1 and this is my y2, this will act as x. This is my x2, and maybe this is my x1. Since we are looking for y, we have all of the other ones. So we start with unknown y minus y1. When you look at this figure is bigger than this. So divided by, when this minus this, then this minus this. Divided by y2 minus y1. What you do here is what you do here. There are two ways. You may opt to say y and x, then x and y, but that one will mean that you are joining two unknowns on one side. So keep y on one side and x on one side by using the gradient thing. So we shall have, instead of this, we start from here, 0.4 minus 0.3 divided by this minus this, divided by this minus, that's what you did here, divided by 0.6 minus 0.3. When you have this, you only have unknown y, because we know this, this, and this. Do the substitution. So we have y, whose figure we don't know, and we are looking for. y1 for this is 3, divided by 3.00, divided by y2, which is 3.22, minus y1, which is still 3.00, is equal to, when you look at 0.4 minus 0.3 minus 0.3, you get 0.1. 0.1 divided by 0.6 minus 0.3, which gives you 0.3. When you get to this, you can either use calculator and get the answer straight away, or do the needful. So we shall have y minus 3.00 divided by 3.22 minus 3.00. So you do the needful. 3.22 minus 3.00. You get 0.22, because so after getting this will be the same as 0.1 divided by 0.3. After getting this, now make it y the subject. So in that sense, you'll have y giving us 0.1 divided by 0.3 times 0.22 when this one multiplies this, and when this one crosses the equal signs, it becomes positive, then plus 3.000. This is what you have. After writing that, so you have 0.22 times 0.1, getting 0.022, then divide by 0.3, you get 0.7, then plus 3, you end up getting 3.073333 recurring. When you look at this, the answers have been given with 2 decimal places. So what you do, approximate this to 3.07, which are 2 decimal places. When you look at the value of y, this value of y shouldn't be beyond. Could you get the value of y greater than 3.22? Then it is wrong, because you cannot have 3.3 here, yet this is 3.2. It is 3.07, which implies that this one suits in between the two figures. It is greater than 3, but less than 3.22. If you have this, then you call this the value of y. So by linear interpolation, you've calculated the value that lie between the values of x, two successive values of x. Now the task is yours. You have Roman 2. Find the value of x when f of x is 3.82. This one is good to do it. Why? Because this one, we are dealing now in the lower part. 3.82 lies in between 3.69 and 4.00, because 82 is greater than 69, but 82 is less than 4. 3.82 is less than 4. So we're going to extract another table with 3 known values of x: 3.69, 3.82, and 4.06. And then 2 known values of x, whereby one value of x lies in between 2 successive values of y. So we need to find that figure here. So extract another table, but make sure that you have an unknown between 0.9 and 1.2, such that you get the value that lies between these two figures. So when you do that, then you understand that you've understood how to use linear interpolation. Thank you so much.